Alright, let R be the region in the first quadrant bounded by the graph of y equals 2 square root of x and the horizontal line y equals 6, and the y-axis as shown in the figure above. A. Find the area of R. In order to find the area of R, we're going to take the integral going from 0 to 9 of the top line, the top function, minus the bottom function. Then we're going to take the antiderivative of each side and do the fundamental theorem of calculus after that. Once we get the antiderivative and we're doing the fundamental theorem of calculus, we're going to evaluate on the interval of 0 to 9, which gives us an answer of 54 minus 4 times 9 to the 3/2 over 3. And since that is completely numerical, we can just leave it as that, so we don't make any unnecessary mistakes in the algebra. And B asks, write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line of y equals 7. So just for visual aid, we're going to draw a horizontal line at y equals 7. And it's going to be rotated about that. So it has a gap. So we're going to take the pi times the integral going from 0 to 9 again of the big radius squared minus the little radius squared. So we take pi going from 0 to 9 of that top line 7 minus the very bottom function 2 square roots of x squared minus 1 squared, because the difference between the top line of 7 and that horizontal line of 6 is just 1. And then that's the answer because it asks to write but do not evaluate. C states that region R is the base of a solid for each y where y is greater than or equal to 0 but less than or equal to 6. The cross-section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base in region R. Write but do not evaluate an integral expression that gives the volume of the solid. So to start out with, we're going to write the basic equation to find the area, which is the integral going from a to b of the area of x dx. And ax in this case is a rectangle. And in our problem it says that the height equals 3b. So in order to get x alone to plug into our equation, we have to solve the bottom equation, which dividing by 2 and then squaring each side gives us that y squared over 4 equals x. And then we plug that into the 3b squared. So we get 3 times y squared over 4 squared. And then we're going to plug that into the integral, but we're going to pull the 3 out as a common multiple. So we take 3 integral going from 0 to 6 of y squared over 4 quantity squared dy, and that is the area of the rectangle. Points for this question. So in an A, there were 3 points awarded, 1 for doing the integral, 1 for having the antiderivative, and then 1 for having the answer. Yeah. And then for part B, there were also 3 points awarded, and there were 2 points awarded for the integral, remembering that there's a gap, and then 1 point for the limits plus the constant. And part C, there were also 3 points awarded, 2 for the integral of the equation, and then 1 point for the answer.
Don't call him Jens. Don't take Harry Potter's side during the debate. Don't forget plus C. Don't be late. Don't take advantage of homework being due in 2 days. Don't take the AP test lightly. Do's. Pay attention in class. Ask questions in class. Always yell, the derivative is the slope of the tangent line. Do donkey kicks when told to. Do your homework. Do take the AP test seriously. That's all of them.
This is where I spend most of my time. In my calculus book. But let me tell you why I love it. I love calculus because I love having an understanding teacher who will go over things if we have questions. I also love being able to apply calculus to everyday life, such as the velocity problems that we go through. I also like the amount of time that we got to study for the AP test, and I love the work days.
I love watching The Big Bang Theory. I also love Mr. Levinson's collection of ketchup. And I love the 2 days we get to do homework in class. Why do I love calculus? Well, let me tell you. I love Mr. Levinson's sense of humor. I love doing derivatives. I also love the Star Wars versus Harry Potter debates.